Check this out. We've got something really fun today. This is so amazing. Oh man, again? Let's warm up. By adding and subtracting rational numbers. Whenever we add or subtract rational numbers, we need a common denominator. Now between these two, we could use 8, but then we'll have to simplify at the end, so it's best to use the lowest common multiple, which is 4 in this case. So we need to make this denominator 4 by multiplying numerator and denominator by 2. That gives us 2 over 4 plus 3 over 4 is 5 over 4, and improper fractions are great. We prefer them. Next one looks like our lowest common multiple for our denominator here is 35. So multiply top and bottom by 5, multiply top and bottom of this one by 7. It'll be 10 over 35 minus 21 over 35, and that's negative 11 over 35. Next is this mess. If we don't have a denominator showing, then by default it's 1. Next we need to have a common denominator between these two rationals, so multiply numerator and denominator by 2. That gives us 2 over 2 plus 1 over 2 for the numerator. This one, same thing, we need a common denominator, so that would be 4. So 3 over 4 minus 8 over 4. Now we can add these two together here, 3 over 2, and we can subtract these two here, negative 5 over 4. And now we're dividing rationals like we did last time. Let's change that to multiplying by the reciprocal. Now, whenever we multiply or divide, we do not need common denominators, so we can just multiply these straight through. So negative 12 over 10, or we could have simplified before we multiplied. In either case, we need to simplify before or after. 6.3, adding and subtracting rational expressions. In general, if we have these two rationals here and they don't share a common factor in the denominator, then we need to multiply the first rational by d and the second by b, and that way they have a common denominator, and this will just equal, in general, AD plus or minus CB, whatever we're doing, and that's over BD. Now, if the denominators already share a factor, we don't want to multiply by that factor again, because then we'll have to simplify it out in the end. So this one has a B and it has an E. This one has a D and an E. So the E is already common. We don't need to multiply by that E. So we just need a D for the first one. Multiply the numerator and denominator by D. And this one, we just need a B. It already has the E. So BC and bed. Now we can add them or subtract them, whatever we're doing, and we won't need to simplify out anything later, hopefully. Example 1, we want to simplify and state the non-permissible values. We need to have a common denominator, so let's multiply this side by 3 and this side by x. Then we've got 6 over 3x plus x over 3x. And we'll just write it as 6 plus x over 3x. Now, since x is in the denominator, x cannot equal 0. Example 2. This one has an a, this one has two a's, so we need one more a on this side. This one has one b, this one has two b's, so it looks like we need another b on this side. Now we have 2a over a squared b squared minus 8b. And since a and b are in the denominator, neither one of them can equal 0. Those examples were fairly easy. Here's some steps for when it gets a bit more complicated. Factor all the numerators and the denominators. State the non-permissible values. Remember, they come from the denominators. Rewrite using lowest common denominator. Keep the denominator factored. Add or subtract numerators combine like terms so that we can look for common factors that may be simplified away. Example 3, the denominators are already factored, so we're okay. Let's just do the non-permissible values first. X plus 3 cannot equal 0. Minus 3 on both sides. That means that x cannot equal negative 3. And you don't have to show all those steps if you can just do that in your head. X plus 2 cannot equal 0, so that means that x cannot equal negative 2. So those are our two non-permissible values. Looks like we have a binomial here and a binomial here. They go together. They're stuck together like a family. So this one has an x plus 3 family, and this one doesn't. So this one has an x plus 2 family, and this one doesn't. We need to multiply the left term here by x plus 2, because it doesn't have an x plus 2 family. And the other one needs an x plus 3, because it doesn't have that family. They go together. You can't just mess about in here and change the binomial. Now that we have this, we can multiply in the 5 and in the 8, rewrite it all over one denominator, because now the denominators are the same. So 5x plus 10 plus 8x plus 24 all over x plus 3 and x plus 2. Don't multiply these together because we don't need to. It's just extra work. Add these up, collect up like terms, so 13x plus 34 over x plus 3 and x plus 2. And there's nothing common between the numerator and the denominator, so we're done. For this one, this has an x plus 3 family, and this one doesn't. So let's multiply the denominator and the numerator by x plus 3. Don't just write it beside, because then it just looks like we're multiplying by the 1. You need the brackets around each binomial. This one has a 4, and this one does not have a 4. So let's multiply numerator and denominator by 4. Now we can rewrite this all over the common denominator. We have 4x plus x plus 1, x plus 3, all over 4 times x plus 3. Now we could look for non-permissible values anytime. Let's do it. X plus 3 cannot equal 0, and that means that x cannot equal negative 3. And now we look at this. Now we don't want to multiply the denominator together, but we do want to multiply the numerator together because there's some terms we could probably collect up. So let's do that. We've got a 4x plus, now we're going to use the distributive property here, x squared plus 3x plus 1x plus 3 all over this denominator. Now we'll collect up like terms, x squared plus 8x plus 3. And then we do a quick check. Can we factor this? And more importantly, is there an x plus 3 factor in here? Or even a 4? And there isn't, so we can't go any further. We want to subtract these and state the non-permissible values. First step, let's factor and see what this denominator holds. So it's a difference of perfect squares. That means it's x plus 2 and x minus 2. Now the other denominator is already factored, it's just x plus 2. And you notice that we have a common portion of our denominator here already. That means the only thing this denominator is missing is the x minus 2 family. So let's multiply numerator and denominator by x minus 2. Let's also get our non-permissible values, so they are coming from the denominators only. X cannot equal plus or minus 2. Now let's go on. We can rewrite these together because they have a common denominator, so 3 minus. We can also distribute in the negative 8 or the minus 8. So minus 8x and plus 16. Keep the denominator factored, do not multiply it together. We want to see it in its factored form at the end. Now you have 3 plus 16 is 19, and the denominator stays the same. We look for a common factor between the numerator and the denominator, and we don't have one. So we're done. Example 6, we want to add these all together and state the non-permissible values. So first step, I'm going to factor 1 over a minus 3 plus 1 over a minus 3, a plus 3 minus 1 over a minus 3, a plus 1. Now we can see all of our factors here. So we could do our non-permissible values. A cannot equal 3. A cannot equal 3. We already got that one. We don't need to write it again. Negative 3. 3 again. We already got it. And negative 1. Okay, so there's our non-permissible values before we forget. Now we can go on. We need a common denominator. This one has an a minus 3, this one has an a minus 3, and this one has an a minus 3. So that's all common. We don't need to worry about that. This one has an a plus 3 though, and so this one needs an a plus 3, numerator and denominator. And this one needs an a plus 3, numerator and denominator. Now the only thing that denominator is missing is this has an a plus 1 family, and so this one needs an a plus 1, numerator and denominator, and this one needs an a plus 1, numerator and denominator. And now we have all three binomials common in our denominator. So now we can rewrite this as one fraction. We can also multiply it together. So this is a, as in these binomials up here, I guess this is the only one, a squared plus 1a plus 3a plus 3 plus a plus 1 minus. Now watch out for this minus sign because it applies to both of these. So minus a minus 3 all over a minus 3, a plus 3, and a plus 1. Do not multiply those together. We want to keep them factored. Collect up like terms. So we've got a squared. We've got 4a, 5a, back to 4a. And we've got a 3, 4, minus 3 leaves us with 1. And we look at the numerator and see if we could factor it. And in this case, we can't factor this. So we're done this question. This one, we could work together with the numerator and then the denominator. We could say this one needs a common denominator of x, so we'll multiply numerator and denominator by x. That will give me 1 over x plus x over x. In the denominator, the same thing. So this is 1 over 1. I need a denominator of x, so x times x. This one will be x over x minus 1 over x. Now I've got a common denominator, so I can say this one is 1 plus x over x. And then this denominator would be x minus 1 over x. And now I'm dividing by a fraction, so I could change that to be multiplying by the reciprocal. And so we see here that the x's can cancel, and I'll be left with 1 plus x in the numerator and x plus 1 in the denominator. Now I didn't find the non-permissible values, and I have crossed something out here. There was an x in the denominator. There was an x minus 1 in the denominator. And there's an x in the denominator. So x cannot equal 1 or 0. Now let's do this question a different way. So we'll put an or here. This one's a bit harder. You might have noticed that there's a 1 over x in the numerator and in the denominator. So we could actually factor that out. 1 over x. So in the numerator, 1 over x, and when I factor it out, that's 1 plus x. In the denominator, I factor out a 1 over x, and I get x minus 1. I get my non-permissible values of 0 and 1 here, and then I have a common factor I can cancel, and I'm left with the same answer we got above, but perhaps a bit quicker. This was part of algebra number 5. We were performing operations on rational expressions, and that would be adding and subtracting, as well as finding the non-permissible values. Here's some questions, see if you know what you're doing.